my today's topic is data structures. Let us see what is data structure, classification of data structures, and operations to be performed in data structure. So let us see what is data structure first. Now, data structure is a way of organizing, processing, retrieving, and storing data in a computer so that it can be easily accessed and efficiently as well. So organizing means how the data is being stored, how the data has to be stored, or how the data has to be organized in the memory. And processing means data itself is a raw data. Data itself is a raw data. So processing means we are turning the raw data into the meaningful information. And retrieving data means we are accessing the data from the memory. So we have set of algorithms which tells us how quickly the data can be retrieved. And storing data is basically how the data is stored in the memory. So let us see the classification of data structure is classified into two types. One is primitive data structure and one is non-primitive data structure. So primitive data structure is basically the data structure which are predefined or which are defined when the program is being designed. And non-primitive data structure is the data structure which are derived from the primitive data structure, and also it is user-defined data structure as well. So primitive data structure means basically we can give example of int, char, string, boolean, etc. So these data structures are coming with the package of C, and it is not easy to modify. These primitive data structures. So non-primitive data structures, whereas the user-defined data structure can be modified or can be changed in the by the user or the programmer. So non-primitive data structure are classified into two types, that is linear and non-linear. Linear data structure are the data structure which where the data are stored in the sequential order. And we have two types of linear data structure, that is static data structure and dynamic data structure. In static we have array, and in dynamic we have linked list, stack, and queue. Static data structure is basically the data structure where the size of the or the memory allocated for the data or the array will we cannot change the size of the array. Next, dynamic, we can change the size of the array, size of the list can be changed. Next, non-linear data structure basically are having the hierarchical relationship with the main data item. Next, we'll see linear data structure. Linear data structure have all their elements arranged in linear or sequential fashion. Now, each element in the linear data structure has previous element and the successor element, that is the next element. Example for linear data structure is array. Next, non-linear data structure is a kind of data structure in which data elements are not arranged in sequential order. So here the data will be stored in the memory. In the memory location, the data will be stored randomly anywhere in the memory band. Next, there is an hierarchical relationship between individual data items. Example for non-linear data structure are tree and graph. Now array. Let's see what is array. Array is the simplest type of data structure in linear data structure. So array refers to the orderly arrangement of data element. Now here in array, the datas are arranged in particular pattern. Like when we give array and the size, what happens in the memory band is the set of memory will be allocated for that particular variable. Next, array is a type of data structure that stores the data element in adjacent location. And here in array, data will be stored in adjacent pattern. So one after the other, the data will be stored. It is in the continuous form. Next, it is also called as linear homogeneous data structure. We call array as linear homogeneous data structure because it can take only one particular type of data. For example, if we declare int as array, next what happens is array will take only the integer value. It will not accept the string value or the character value in its list. Next, types of array. The simplest form of array is one dimension array, where we give only set size of the array, and two dimension array are the array which where for example, we can take matrix, and multi-dimension array we have many set of rows and columns in the multi-dimension arrays. Now, for example, for one dimension array, int num is equal to, and we have the set of numbers. So we'll see how the data that is the values 26, 7, 67 are stored in the variable num. So here we have index in the index for each elements of the array. So 0, 1, 2, 3, 4 are the index of the array. Next, the smallest element of the array index will be the lower bound, that is 0 will be our lower bound, and the largest element is the upper bound. So 4 will be the upper bound. Since the array starts from 0, since the array is starting from 0, the size will go to n minus 1. If the array would have started from 1, then the size will be till n is equal to 5, because we have set of 5 elements in the, we have given the size 5 to the variable num. Now the smallest, the number of elements within the bound are called within the range. Next, two-dimension array. It consists of multiple rows and columns of data. Now, for example, we can call it as matrix also, where we have rows as well as the column. So now here we have an example where int a of 5 and a of 7. So we have one set of row and we have one more as column. Multi-dimension array. Multi-dimension array is a 3D representation of array, where we have n and n, we have n number of rows and m number of columns. Now we'll see linked list. A linked list is a data structure in which each data element contains a pointer or the link to the next element in the list. So we'll see in the next one, we can see we have two nodes. One is address node and one is the information node. So we have in address node, we have address pointing towards the next element in the list. Next, through linked list, insertion and deletion of the data is possible at the place of linked list. So in array, it was difficult to insert or to delete the element from middle of the list, but in linked list we can easily insert and delete the element from any place of the list, from the list. Next, it is not necessary to have data elements stored in consecutive location. So in array, it was like we had to store the data in continuous pattern, but in linked list there is no necessary to store the data in continuous format. So here the memory will be saved. If it allocates space for each data item in its own block of the memory. So here the memory manager will decide where the data has to be stored. Each node in the list contains information field and the pointer field. So information field will have the actual data of the list, and the pointer field have the address of the next node or the next element on the list. Now pointer at the last contains null, because the last element in the list will not be holding the address of the other next element, so the pointer field will be null. Now let's see stack. Now stack is a linear data structure in which insertion and deletion of the element are done at only one end. So in stack, insertion or the deletion will be done in the one end. So it is like in a box you have, in a box you have pile of books. So if you have to take the book from the bottom, you need to pop out all the books at the top. So once the top books are cleared, then only we can take the books from the bottom. Now, a stack is called last in first out structure. So stack follows LIFO format, that is last in first out. First out. The last element which is being inserted will be the first element to be popped out or to be deleted from the stack. In the computer's memory, stack can be implemented using array and linked list. Now let's see queue. Queue is a first in first out data structure in which the data inserted to be taken out. So in a queue, for example, we stand in a queue of for buying some ticket of a movie. So how the queue performs, same way here the queue operation also be done. So the first person who is standing in the queue will be the first person to move out from the queue. So it is first in first out. The element in the queue are added at one end and is called rear end. So we have two open ends, that is one end that is the rear end and other end is the front end. So in rear end the insertion will be made and from the front end the deletion will be made. So like stack, queue can be either implemented by using array or the list. So we can perform next tree. A tree is a non-linear data structure in which the data is organized in branches. The data elements in the tree are arranged in the sorted order. So it's like it is a non-linear data structure. So the data are to be stored in the not consecutive location. So in which the data is organized in branches. In tree, the data are organized in branches. The data elements in the tree are arranged in sorted order. So the elements here should be in sorted order. To impose, it imposes a hierarchical structure on the data element. So the here in tree node we have a relationship between each nodes. So the first node we call it as a parent node, and the other nodes are the sub nodes are called as child node. So there is a relationship between the nodes. So here you can see tree structure of employee. Graph. A graph is a nonlinear data structure. In tree data structure, all data elements are stored in definite hierarchical structure. So in tree we had structures, and each structure had the relationship between each nodes. There was a relationship between each nodes. So each node had only one parent node, while graph, each data element is called vertex. Now here in graph we call the nodes as vertex and the connection between the nodes as edges. So the graph is considered as the mathematical structure which is composed of a set of vertex and a set of edges. So there are set of vertex as well as set of edges. We can see the graph in the other side of the PPT where we have A, B, C, D, E and F. Now the A, B, C, D, the alphabets are called the vertex, and the connection between the each nodes or the vertex is called edges. Now the operations on data structure. The operations performed on the data structure are traversing, searching, insertion, deleting, sorting and merging. So traversing means to access each data item exactly once so that it can be processed. So here what happens, each data element in the list will be visited at least once. So all the elements has to be visited. For example, let us take to print the name of all students in the class. So now when we have to print names of all the students in the class, each student name will be visited at least once. So each student name will be printed. So searching, it is used to find location on It is used to find the location of one or more data item that satisfy the given constraint. Such a data item may or may not be present in the given collection of the data item. That is, for example, if we have to find the name of students or all the students who have secured 100. So in that, what happens, the data will be all the students name will be searched, at least all the students name will be searched, and the student who have secured 100 will be executed. So searching, it takes one key element and it searches for that particular key element in the given set. So in case it can be successful search or it can be unsuccessful search as well. So inserting is to add the new data item to a given list of the data item. So we have a set of given data list, and we are adding one more data item to the list. That is known as insertion, when we have to add one more data element. For example, adding new student detail will be the example of inserting data. Next, deleting. It means to remove or to delete a particular data item from the given collection of data. So we have set of data here as well, and we are deleting one name of a student or one item from the list, from the given list. Sorting. Data item can be arranged in some order, like ascending order or descending order, depending upon the type of the application. So sorting means basically we are arranging the given set of data in particular order, that is ascending order or the descending order. For example, in ordering names, we can follow the alphabetical order. Next, merging. Merging is basically a list of two sorted data. So we'll have data items. We have two set of sorted data items, and we are combining the both data item to form a single list. Thank you.